the processing of the ROMEX data. Thank you, Chris.
Thank you very much. If you think I'm up here too much, I agree, and I promise this will be the last time for that week and for next week for this workshop. And in the coming hours and days, I will just mumble in the background and complain about commercial data providers and things like that. I wanted to talk about this initial data set that we provided on the ROMSAF server for all the NWP centers to work with. Over the last couple of weeks, I've heard a couple of rumors what we have done and not, so I wanted to clarify that. As usual, I have totally underestimated the amount of work that was coming into that. That is why things came very late, and I do apologize for that. In addition, things happen like broken feet and stuff. But all the data in the end will arrive on the ROMSAF server. We also have contributions from Noah Star and from Yuka, who have reprocessed both reprocessed parts of the data, and they will be available very soon as well. So I want to go quickly through a few details on the data quality and also on the status of the ROMSAF server. And as I've started to think about what I do think about things, I have some lessons learned that I spread in between, which are my personal thoughts, and you will find your own opinion on that. So let's start. Hui already mentioned that we have this all ROMEX run, that is all the occultations that we have. Here is a time series of the daily numbers, and the individual colors are the individual missions, so you can try to find them in there. We have a baseline, which is essentially the current data which is available operational, minus the commercial data and minus the Fengyun 3 data, because not everyone is using the Fengyun 3 data. And then we agreed on the ROMEX workshop, we do a 20K data, and this is one proposal that we had, and I actually don't know who came up with the idea. It might have been Neil or Katrin, I'm not sure. What we have been doing here is we are using the baseline, we are adding Planet IQ, and then we are using the pool of Spire data to fill up to 20,000 occultations a day. That's one proposal which does not include or does not try to address this local time issue. So we will have to discuss if we can do better than that. The initial idea for setting up that core data set was we use the operationally available data, we repackage it, put it on the server, and everyone is happy. That worked perfectly well for the Yuka process data, in particular Cosmic 2, COMSAT 5, PARS, TerraSAR, and Tandem X, and the few geo-optics data we have during that period. And it also worked reasonably well for the GRASS data that was processed by us and the Sentinel-6 data where we had the reprocessed version already. So that was a no-brainer. And then we came to some missions where we had to do a little bit more work. And I start with with what we have done at EUMETSAT to make that data set available. And so first I start with the Chinese data, or part of the Chinese data. So that is CMA, this Fengyun 3 data from, they provided us data from 3 satellites, of which only 1 is operational. And Tianmu is a startup that at that time had only a single satellite, which provides maybe 270 or so occultations per day. We got high resolution bending angle data, but no buffer or anything. So we reformatted that, turned that into buffer, and we thought that the Fengyun 3 data has been used in operations in some centers and also in China. And I didn't spend enough time to look into that very early on. And in retrospect, I should have done that because we have some issues in those data sets. On the other hand, especially Tianmu is one of the smallest data sets, so the impact on the ROMEX result will not be that big. We will go through reprocessing activities, and I come to that a little bit later. But for the time being, there might be something that you consider as points to remember when you use the data or when you have used the data. Planet IQ, we are very grateful for you to providing your data for free for ROMEX. There was no payment or anything involved. You dumped us with a lot of data, and when starting to count the profiles, I found that, so first of all, what we asked all the data providers to give us is bending angle data, high resolution, ideally in buffer, thinned, and also excess phase data. We didn't get any lower level data. So excess phase is always the lowest level, and that's what we based the reprocessing on. When we counted the Planet IQ data, we found that there are, fewer bending angle files, and there are excess phases, which makes sense because in the processing you throw something out. Although we found that the amount of profiles that was missing was a little bit high. And then we went to the buffer data. We found another drop in numbers. And when we talked about that, we got the response that, no, that shouldn't be the case, but they don't have time. And after all, of course, they were not paid. So do with it what you want. And then at the time we were preparing for processing the Planet IQ data. So we ran it through our processing. We found out that we increased the number of bending angle profiles that passed our quality control was about 10 to 15% higher than what we got in terms of bending angles from Planet IQ directly. And we thought, well, the data looks excellent. We use that and we put it on the server and we hope everyone is happy with that. We asked, I think, and more or less we said, that's okay. So that was great. Spire posed another very interesting problem. We had the freely available data from the NOAA database. We had the freely available data from the EUMETSAT database. We had the data that had been unlocked by NASA from the CSDA project, which probably was something like a combination of the two minus some, because also the CSDA data didn't have any Beidou data. But Spire donated the rest of the Beidou data that we hadn't seen before. So we had something like 3 or 4 different data sets with different file naming conventions, and we would have gone through it and picked the individual occultations from each side. And then we saw, wow, that's a lot of, 17,000 occultations a day. So, and then we talked with Wu, and he was willing to give us the entire set of access phases, and we processed it because we are doing it operationally, and most people are happy with what we are doing. That is why we reprocessed Spire, to have a consistent Spire data set processed from access phases, like we reprocessed Blend IQ data from access phases. Yunyao, a big data set between 6,000 and 9,000 occultations on some days. They did have quality issues in their very strange features. They are a young company in China. They didn't have any experience with processing data. We sent that through our processing and we found that the data was actually looking very nice. And I show you some examples of that, apart from what's happening in the lower troposphere. And we talked with them and we discussed, and in the end they said, yeah, that's okay for ROMEX if we reprocess the data and we put it on the server, then they will be happy with that. They want to work with us to learn what we are doing differently so that in the future they can do better. And we are trying to do that. So that is why we reprocessed Yunyao. In retrospect, as I said, we should have spent more time on the CMA data and TMU, but the numbers are really low. So they were kind of, in the beginning, they were at our lowest priority. And I do apologize to Chong Liang and the people in TMU and NSSC, who I might have disappointed, but we continue working on the data. Here is a table with average numbers and what we have done to each data set, so please consult it. This is the baseline. This is what we get with the full ROMEX. That's the difference, right? The geographical distribution is fantastic, as Hui already pointed out, when you look at the individual missions. So let's skip that. The local time distribution, this is, I think, on a single day, is not that good. We have a clustering of occultations around 10 or 9:30, where we already have METOPS. On 16th of August, we had the Transporter 11 launch with the Planet IQ Gnomes 5 and 6 satellites from Spire, and they are all at 10 o'clock local time. So we are clustering satellites there, and I don't think that's good. We need to find a way to improve on that. So the baseline missions, that's the statistics, and it's always the same. We have a bias very high up, and we have a standard deviation. I come to the rest one, and this is globally, and this is in the tropics. And all these missions look on that scale reasonably similar. What you see here is a robust statistics, and I come to that, oh yeah, thanks. I come to that on the next slide while we do it like that one. There are differences between the data set. In a way, I think they are maybe more representative of the data center than of the actual quality of the data. If you want to have a bump around 20 kilometers, in your standard deviations, use UCA data. If you want to have data that goes a little bit farther down, especially in the tropics, use UCA data. If you want to have a smooth transition around 20 kilometers, use EUMETSAT process data. We are looking into these differences, also by having the data reprocessed by different centers, and I think it's important to do. We also think that the differences do not warrant to say that one processing or one data set is significantly poorer than the other. They are both used in operations. People have good results with it. So we think that despite the small differences we find, and I'm expecting that over the next few days, we will discuss biases in the lower tropical and subtropical stratosphere quite a lot, especially for COSME 2. They will not prohibit us from getting good results for ROMEX. So these are the baseline missions. Yeah, I wanted to come to this one. We are using robust statistics, as Hai Ling pointed out. Data that goes into NWP models ideally should be distributed Gaussian, normally distributed. In reality, data never is that. You always have outliers. This is a branch in statistics that is trying to identify the subset of the data that is normally distributed, remove the outliers in some iterative way, and then estimate the characteristics of the normally distributed data. So it is kind of an attempt to simulate a QC without really knowing what you have to do in the QC, but trying to find out what you would get as a kind of statistics when you have done a really good QC. And we have done, here is a long write-up, I don't want to go through them. What I want to say, we have, within ROMEX, we have gotten some data from Spire, for example, that has been heavily quality controlled on the vendor side. We have been gotten data, especially from China, that had seen no quality whatsoever, and we didn't try to apply any apart from, you know, the Yunyao data went through our quality control, but the Fengyun 3 and TLMU data didn't. We have other where we are not sure if you got from Planet IQ, for example, if there was any quality control or not. Just using ordinary, normal statistics, calculating things, finding in the end that there are outliers, and then arguing, well, this mission is very poor and the other mission is great because it had all these. You know, that's poor science. Sorry. If you are comparing so many different missions with so many different approaches to quality control, there is a better way to do that to get an idea of what the bulk of the data look like. And I'm running over time, I know. These are the commercial missions, and I want to highlight the light blue one is Planet IQ, that is actually behind the violet one, which is Yunyao. So Yunyao, in terms of standard deviation in global statistics, looks excellent. There's one mission that stands out below 5 kilometers, and that is Yunyao as well, with large standard deviation, huge biases. The others are, again, I think, reasonably consistent. The gray lines are GRAS, and down here is Cosmic somewhere. What happened with Yunyao? Yunyao, again, an unexperienced young team. They didn't trust the excess phases below -100 kilometers. And as we know from groundbreaking work from Sergey, if you are cutting off too much signal too high up, then you're creating negative biases, and that's precisely what we see here in the reprocessed data already. That is why I don't like cutting off data. Yes, I should shut up. Right. Thank you, boss. What's coming? The version 1 is there. Some of the data sets didn't have reflectivity. By now, we have nearly all reflectivity done. Just a day before I came here, the ROMSAF provided me with the reflectivity data for Yunyao that will go on the Spire, on the ROMSAF workshop. The 20,000 data set will appear there. Yuka and Noah star process data will appear there. Katrin is producing a data set or preparing a data set with operational ECMWF analysis to aid the things. Some things take too long, like putting data on servers or me talking, so I shut up now.
Thank you, Chris. Didn't mean to shut you up that quickly. We have time for a question. Rick, do you want to go first?
Well, I've been one of the complainers about things taking so long, and I get sent these emails, but I do want to say that I understand and that you're doing this for free, basically, and it's not easy. And so thank you very much. That's the main point here. But on the question of refresh rates or age of the observation, it would be possible for the centers themselves to break the full data set into early observations and late observations, the ones that are closest to the analysis time and the ones that are farthest away in the two sets, and do that kind of study, right?
Are you looking at me?
Yeah, I mean, we could ask Chris to do it. Produce two, divide the entire ROMEX data set into the oldest and the most recent somehow, but the centers can do that themselves, right?
Yeah, anything's possible.
Well, okay.
There is one thing I would like to note, because we mentioned it. We have a problem with the local time distribution. I doubt that we can generate a homogeneous local time distribution based on the data set we have, because the 6 o'clock orbit, 6:30 orbit, whatever, the early morning orbit, 6, so 6, dusk dawn. There is really only one mission, which is Fengyun 3E, I think, which is providing data there. So it's a single mission only, and that will not fill up all the gaps we have. So it will be difficult. But if there is a desire for doing that, maybe we have 10 minutes on tomorrow in the NWP discussion where we could think what the priorities are, and then we see.
Okay, thank you. I'm sorry, Ben. We're going to have to move on to keep to time. So our next speaker is Jan Weiss. So he's going to be talking on results from the CDAC processing of the ROMEX data.
All right, thank you, Neil. Good afternoon. I'd like to recognize the team from UCAR that's been working on this. I'd